and gentlemen, welcome to the video demonstration of brand new medical wastewater treatment system using JOHKASOU and MBBR technology. This video is based on the PHÁT TRIයෙන් Hospital project, Myanmar. The project is implemented by PureCare Myanmar and Fudeso, Viet Nam. Let's get started now. Let's get into the topic. The project's business is hospital. Wastewater is generated from toilets and clinic areas with a total capacity of 40 m3 day and night. Wastewater is collected by pipes to the equalization tank. The quality of the input water is projected as shown on the screen, with important pollution parameters being pH, BOD, COD, and suspended solids. The requirement is that the treated water must meet Myanmar's national discharge standards. After research, we found that the JOHKASOU tank, using MBBR technology combined with a pH neutralization, meets the requirements and is suitable for the project's investment cost. Now let's see how we do it. FRP composite wastewater treatment tank is fabricated, inspected, water leak tested, and all equipment and pipes are installed inside the tank at Fudeso's factory in Viet Nam. This process takes 30 to 45 days from the date of purchase order. And then tank and all equipment are then carefully packed in a container and taken to Hai Phong Port, Viet Nam, ready for delivery to Myanmar. The ship will carry cargo from Vietnam by sea, transit through Singapore, and arrive at Asian World Port in Yangon, Myanmar. This ship takes 20 to 30 days. Goods will then be transported to the construction site by truck. Now let's take a closer look at what the construction site looks like. This is the project perspective. The wastewater treatment plant will be located on the north side of the hospital, next to the parking area. The inlet will be on your left. The water will overflow into the concrete equalization tank. The FRP tank is placed underground. Above is the operating area, including electrical control cabinet, 2 air blowers, and chemical supply system. Equipment is mostly from popular brands in Japan or EU or G7 countries, has a long service life and easy to find replacement parts. In addition, the air blower has a noise level below 80 decibels, does not affect the surrounding area. I will continue the work after the shipment from Yangon Port to the construction site. The concrete equalization tank and construction items such as digging holes, building surrounding walls, pouring concrete for the control area were carried out 1 month in advance and completed before the tank was delivered to the site. Tank is lowered into the pit by crane. Engineers will fix anchor cable to secure the tank, then fill the tank with water to 2/3 of the tank. This helps the tank to be fixed and not float after filling with sand. This process only takes 1 to 2 days. The equipment's outside tank was also delivered and installed 2 to 3 days later. Then technicians will proceed to connect the pipes from the tank to the air blowers, electrical cabinet, and chemical system, as well as from the equalization tank to the FRP tank within 5 to 7 days. Finally, the construction contractor will fill the sand and backfill the site to ensure the aesthetics of the area. Thus, the total time from ordering to completing all the work only takes about 2 to 3 months. Quite short compared to the option of using a completely concrete tank. Let's see about the structure of the JOHKASOU tank to see how it treats wastewater. Wastewater from toilets often contains human feces, toilet paper, sanitary napkins, etc. These large impurities can easily clog pipes and equipment. By the basket screen, these wastes are retained. Only water can continue to flow. This mesh basket screen has a slide bar and pull chain to lift it up, making cleaning easier than ever. After separating the waste, the water will flow to the bottom of the equalization tank, where there are raw air distribution pipes, helping to mix the wastewater so that it has a uniform concentration of pollutants. Wastewater is then pumped by 2 equalization pumps to the flow control box to evenly distribute the water flow to the next tank compartments. Pump operates according to signal of water level switches. Water is sent to the anoxic tank. Here, a submersible mixer is installed to help mix the substances and create an anoxic environment to carry out the denitrification process. Water then overflows into the MBBR tank. This is an improved technology from the traditional aerotank activated sludge technology by adding to the wastewater media with high mechanical strength, large surface area, and good adhesion. Now let's learn more about these MBBR media. MBBR media is like a house for microorganisms, where they continuously grow, develop, degrade, and repeat this process. This creates many layers of microorganisms on a media surface, and this is an important factor that makes MBBR technology more stable than traditional aerotank technology. For example, if there is a sudden change in the inlet wastewater, such as a sudden increase in flow or a sudden increase in pollution concentration, or a long-term power outage, microorganisms in the aerotank are very vulnerable due to lack of protection or adhesion. They will be shocked, die en masse, and drift with the sludge, leading to loss. Raising microorganisms will be very time-consuming, taking 1 to 2 months. The same case with MBBR technology is different. Only the outer layers of microorganisms are affected and lost. The inner layers of microorganisms still exist, and they continue their development process, creating many new layers of microorganisms to replace the old layers. This is the reason why MBBR technology has better endurance and stability. And the time to recultivate microorganisms after mutation will be much shorter, only about 1 to 2 weeks. Not only are there many layers of microorganisms, on one media surface there are also 3 types of microorganisms present at the same time. Anaerobic microorganisms in the innermost layer, anoxic microorganisms in the middle layers, and aerobic microorganisms in the outermost layers. This helps MBBR have higher treatment efficiency and a smaller tank volume compared to aerotank technology, which requires you to create environment for each type of microorganism separately. Last but not least, Fudeso uses media made from HDPE or polypropylene, which have a lifespan of up to 50 years according to the manufacturer's research. No require annual replacement or replenishment during use. Bottom of the MBBR tank, there are fine air distribution discs, which both provide oxygen for microorganisms and help the media move to all corners of the tank, so that microorganisms can have maximum contact with pollutants in wastewater to treat them. This is an advantage compared to using a fixed media in an aerobic tank. The area above often has dead corners, causing sludge accumulation, odor, and exceeding pollution parameters. Water from the MBBR tank overflows to sedimentation tank. Water runs from bottom to top. In this process, suspended solids and sludge produced by the biological treatment process settle to the bottom of the tank. The water continues through the filter box to remove remaining floating sludge and then runs to the disinfection tank. Water is passed through a disinfection box containing chlorine tablets to remove disease-causing microorganisms, also known as coliforms. At this point, the water has been treated and is pumped out. Water after the MBBR tank is rich in nitrate and will be pumped back to the anoxic tank to carry out the denitrification process. The sludge at the bottom of the sedimentation tank is pumped to the sludge tank by sludge pump. Every 6 to 12 months, this tank needs to be desludged. Now I will talk about the pH neutralization mechanism. The pH sensor is installed in the equalization tank. This sensor will regularly measure the pH value of the wastewater and send a signal to the control cabinet. The cabinet has a screen displaying the pH value measured by the sensor. Then, the cabinet sends a signal to 2 chemical dosing pumps installed on chemical tank. These 2 pumps will pump natrium hydroxide and HCl into the equalization tank to neutralize. This design utilizes the aeration system at the bottom of the equalization tank to mix chemicals with wastewater. For example, if the measured pH is below 6, the base pump will operate to pump the chemical until the received signal is between 6 and 8. The pump will stop working. The operation of the acid pump will also similarly. With the above structure, let's see how the processing efficiency is achieved. That's all. I think it is the time to say goodbye. If you liked this video, please leave a like and subscribe to support us. If you have any questions or concerns, do not hesitate to contact us via email and phone number below. Don't forget our motto, Sustainable Foundation, Bright Future. See you in the next videos. Note: this project is implemented by PureCare Myanmar Company and Viet Nam Future Development Solutions Joint Stock Company, also known as Fudeso. The video is made by Fudeso. Please do not copy in any form. Thank you.